Hello everyone. Once again, this is Mom Joy and I'm here to help you out in your next math journey. This video will present lessons on subsets of real numbers. This might be new to many of you, but don't you worry, this is not that hard to deal with. First, let's go through the following points to consider and remember. So please take note of the keywords that are very important in this lesson. Okay, let's begin. A set is a collection of objects. The objects are called elements or members of the set. Set braces using these symbols are used to enclose the elements. Sets are denoted by capital letters in the alphabet. Elements of sets are denoted by lowercase letters. If we can count the number of elements in a set such as 1, 2, 3, it is a finite set. If we consider the counting numbers 1, 2, 3, and so on, it is an infinite set. The symbol epsilon is used to show that an element is contained in a set. For example, if A is the set of elements 1, 2, and 3, then we can say 2 is an element of A and 3 is an element of A. Set A is a subset of set B, written A subset of B, if every element in A is also an element of B. That is, A is an element of B if and only if A is contained in B. For example, let's say set B contains mammals and A contains elephants. So we can say that elephant belongs to mammals. The set with no members is called the empty set or null set. It is denoted by the symbol, this symbol. Remember, the empty set is considered a subset of every set. Operations with sets. First, we have the union. The union of two sets A and B, written A union B, is the set of all elements that are either in A or in B. Or we could say that in both A and B. The keyword here is or. For an element to be in A union B, it must be in A or in B. In symbols, the definition looks like this. X is an element of A union B, if and only if X is an element of A or X is an element of B. For example, let's say set A, birds, set B, mammals. Now, if we want to have union of A and B, we can list down any birds or any mammals. Okay, so meaning X could be any birds or any mammals. If you could see in the Venn diagram, you see A union B is the combination of all the elements found in A and in B. Next is the intersection. The intersection of two sets A and B, written A intersection of B, is the set of elements in both A and B. The key word in this definition is the word and. For an element to be in A intersection B, it must be in both A and B. Or in notation, we can write that as X is an element of A intersection B if and only if X is an element of A and at the same time X is an element of B. Looking at a diagram, you can see that the intersection is the overlapping parts of A and B. It means to say that the element must belong to A and at the same time it must belong to B. For example, set A are mammals and set B are herbivores. And so the elements that contains A intersection B are only mammals that are herbivores. So for example, we can take the elephants, which is a mammal and at the same time a herbivore, or a sheep or a cow. Now let's move on and try to do the following examples. Let A has elements 0, 2, 4, and 6. Let B has elements 1, 2, 3, 4, and 5. And let C has elements 1, 3, 5, and 7. Okay, so for number 1, let's find A union B. So for A union B, we simply combine A and P. So let's write it down. So the elements of A union B are 0. Let's write them in order. 1, 2, we have 3, we have 4, we have 5, and 6. So we just take the numbers from A and B. For number 2, A union C, so we do the same thing. We will just combine all the numbers from set A and from set C. So let's write them again in order. So that is 0, 1, okay, 0, 1, 2, we have 3, 4, 5, 6, and 7. Okay, very easy. Now let's move on to number 3. Now number 3 is A intersection B, meaning we need to find the number that belongs to A and at the same time belongs to B. So what is in A and at the same time is in B? Okay, so 0, B doesn't have 0, 1, A doesn't have 1, but A has both 2. A has 2 and B has 2, and at the same time A has 4 and B has also 4. Okay, anything else? 6 and 5, no. So we only have 2 and 4. Now for number 9, okay, let's read. It says X such that X is an element of A and X is less than 4. So we have to get the elements from set A but less than 4. So what are the numbers that are less than 4? Of course, we have 0 and 2. So this will be 0 and 2. Okay, for number 11, X such that X is an element of A and X is not an element of B, meaning what is in A but we cannot find in B. Okay, first, yes, we have 0 and what else? 2 is there, 4 is there, 3 is not here, but 6 is in A and not in B. So we have 6. So we have 0 and 6. To move on further, let's take a look at once again the set of real numbers. So we have the natural numbers, the whole numbers, the integers, the rational, the irrational, and the real numbers. Of course, don't forget that rational numbers are any numbers that can be expressed as A over B, and irrational numbers are numbers that cannot be written as A over B. So these are the number that does not repeat, and at the same time, they don't terminate. This time, let's see if we can identify which statement is true and which one is false using the previous knowledge that we have on real numbers. Okay, for number 27, every whole number is also an integer. What do we know? Whole numbers are positive numbers, right? The counting numbers. So it is also an integer. Therefore, statement number 27 is true. 29. A number can be both rational and irrational. What do we know? A rational number can be written as A over B, but irrational number cannot be written as A over B. Therefore, these two conditions cannot be present in one number at the same time. So this statement is false. Number 31. Some whole numbers are also negative numbers. We already mentioned earlier that whole numbers are only positive integers. Therefore, they cannot be negative integers at the same time. Therefore, statement 37 is false. 33. All integers are also rational numbers. Okay, rational numbers can be written as A over B, and integers can be positive and negative numbers, and all of them can be written as a fraction. Okay, let's say 5 can be written as 25 over 5, or you can simply write negative 4 can be written as negative 4 over 1. Any of them are considered rational numbers. Therefore, statement 33 is true. One more addition in this lesson is the prime numbers. Can you still remember what is a prime number? Okay, yes. When a number cannot be factored by any other numbers except 1 in itself, it is called a prime number. So please pause the video and try to list down all the prime numbers. Okay, here's a tip. It is easy to find out the prime numbers if you cross out the numbers that are divisible by 2, 3, 4, 5, 6, 7, 8, and 9. And 10 you may also use. After that, all the leftover numbers are considered primes. But wait, remember, 1 is not considered as prime number. 1 is a special number, not a prime number. Now, please pause the video and try to follow the instructions that I gave you. And when you're done, you may continue this video and see if you have listed down all the prime numbers correctly. Have fun! Okay, here we go. After crossing out all the factors of 2, 3, 5 up to 9, you could see here 25 numbers that are left, and all of these are called prime numbers. So I want you to remember them because you will find the next lesson easier if you know these prime numbers. And lastly, let's review prime factorization. We know that a factor is a number that is multiplied by another number to give the product. So for example, 7 times 8 is 56, 7 and 8 are factors, and 56 is the product. But hold on, 7 and 8 are not prime factors yet. So let's find the prime factors. So 56, we can use a 3 factor. Can you still remember 3 factors in elementary years? 56, okay, so we have 7 and 8. We know that 7 is prime, so we stop there, but 8 is still a composite number, so we can still break 8 into 2 times 4, and we know 4 is still a composite number, and we can write it as 2 times 2, And we're done. So our prime factors are 2. How many 2's? 1, 2, and 3. So we write that as 2 times 2 times 2. And then finally we have 7 times 7. Now in writing, we need to use exponent. So we can write this as 2 cubed times 7. There you go. The prime factorization is 2 cubed times 7. Now let's try to factor 144. Okay, but the instruction given to us is to factor this number into the product of primes. And when the number has been factored completely, we write its prime factors from smallest to largest. And maybe let's write also in prime factorization form. Okay, so let's try. So 144 can be written as 12 times 12, and 12 is 3 times 4, and this is also 3 times 4, and 4 is 2 times 2, and another 2 times 2 for the other 4. So what are the prime factors? 2. How many 2's do we have? 4. So it's 2 times 2 times 2 times 2. And then don't forget we have 3 times 3 times 3. So that's the product of primes. And now to write the prime factorization form, we can use the exponents to 1, 2, 3, 4, 2 to the power of 4 times 3, 1, 2, power of 2 or square. Okay, very easy. Now the next one, we're asked to reduce this fraction to lowest terms by first factoring the numerator and denominator into the product of prime factors and then dividing out any factors they have in common. So once again, let's factor out the numerator and the denominator one at a time. So let's start with 5 to 5. So 5 to 5 can be written as 5 times 105, and 105 can be written as 5 times 21, and 21 is 3 times 7. So we have 3 times 5 times 5 times 7. That's for 5 to 5. How about 735? Okay, 735, we can also break that into 5 times 147. And 147, is it prime or composite? Okay, let's review the divisibility rule. This is not an even number, so this is not divisible by 2. This is not a 5 or 0, it's not divisible by 5. But is this divisible by 3? Okay, so how do we know? Let's add the digits. So 1 plus 4 is 5 plus 7 is 12, and 12 is indeed divisible by 3. Therefore, the whole number is divisible by 3. So that will be 3 times 49. And 49 is 7 times 7. There we go. So the prime factors of 735 is 3 times 5 times 7 times 7. Okay, now let's write the equivalent here and then we simplify. So 5 to 5 is 3 times 5 times 5 times 7, and 735 is 3 times 5 times 7 times 7. Okay, now to simplify, we can cancel out the 3. We can cancel out 1, 5, and we can cancel out 1, 7. So we have the leftover 5 over 7. There you go. And lastly, for number 81, we're asked to factor 6 cubed into product of prime factors by first factoring 6 and then raising each of its factors to the third power. So first we write 6, okay, 6 and 6. And now we're asked to factor first, so that's 2 times 3, 2 times 3 again, and another 2 times 3. And then we will need to write the prime factors raising to the third power. So that will be 2. How many 2's do we have? 1, 2, 3. So that will be 2 cubed times 3, 1, 2, 3. 3 cubed. That's it. Okay? And since this lesson is quite long, so my suggestion is you watch this video one more time in case you need to review or in case you have missed any concept. And just wait for a teacher to give you a separate work to practice this lesson. Okay, so that's all for this time, and thank you for listening, and I hope to see you once again in the next video. Bye.